The topic that I'm going to be talking about today is how images are formed by lenses. Lenses are used all around us, which a lot of times we don't see or notice. Anyone who's blind like me relies on lenses to be able to see. Lenses make it possible for us to study the world at a microscopic level, allowing us to magnify images that we otherwise wouldn't be able to see. Advancements in lens technology has not only furthered our knowledge, but has also paved a way for studying the body and has led to many medical and medicinal advancements. We are able to learn about our world at an even larger scale and our galaxy in the universe with binoculars and powerful telescopes which rely on the functionality of lenses as well. These are just a few examples of the many things we use lenses for. In order to talk about lenses, there are two important fundamental concepts to understand. The first refers to the point where light rays come together after being reflected or refracted and is known as the focal point. Focal point is related to how clear an image will be after being reflected or refracted. Therefore, if all the light rays converge onto a single point, the image will be sharp and clear, as opposed to the fuzzy or blurry image produced by rays of light converging onto multiple focal points. The second fundamental concept is focal length, which is the distance between the focal point and the center of the lens. The focal length tells us about the power of the lens, which is inversely proportional to focal length. The power of the lens indicates how focused the light rays converged. A weak lens will focus light into a larger area, making its rays less intense than a strong lens that is able to focus light onto a very small and precise area at a high intensity. Now that we understand the properties of lenses, we can learn more about different types of lenses. The first type that I'll focus on is convex or converging lenses. Convex lenses are able to reflect all light rays that enter it into one location, its focal point, on the opposite side of the lens. The lens is shaped with the sides of the lens bulging out similar to a balloon. This shape allows the lens to bend the rays in towards one location, which is the focal point. The second type of lens is a concave or diverging lens. This lens has two sides that cave in, similar to the shape of an hourglass. Unlike a convex lens that bends light towards one location, a concave lens bends light rays away from each other. The focal point of a concave lens can be found by tracing the diverging rays back to their originating location. Since the focal point is on the same side as the parallel light rays entering the lens, the focal length is defined as a negative value. One common effect of lenses is their ability to distort or change an image. For instance, we can use lenses to magnify or significantly enlarge an image. We could also use them to make objects in our visual field seem smaller and farther away. Another common effect of lenses is their ability to make objects appear to be upside down. It can be tricky to figure out what impact a lens will have on our visual perception of that object. However, we can use a method known as ray tracing to figure out how an image will appear while looking at it through a lens. There are 5 rules of ray tracing that will allow you to determine what an image will look like. First, when using a convex lens, any ray entering parallel to the surface of the lens will pass through the focal point on the opposite side of the lens. Therefore, we can use a ruler to draw a straight line from the object to the lens and another straight line from the lens to the focal point. Second, a ray entering parallel to a concave lens originates from the focal point F. In order to trace this ray, we can trace a line straight through the lens in accordance with the light ray diverging from the lens. Third, any rays that pass through the center of both concave and convex lenses will not change direction. Therefore, you can just trace the ray entering straight through the lens. Fourth, a light ray that enters a convex lens through its focal point will leave the lens parallel to its axis. In this case, you can draw a straight line from the focal point to the lens and trace another straight line exiting the lens parallel to its axis. This rule is basically the same as Rule 1, just in reverse. Finally, Rule 5 states that a ray that enters a diverging lens by heading towards the focal point on the opposite side exits parallel to its axis. In other words, if a light ray is entering a concave lens in the direction of the focal point, it will exit parallel. Now that we're able to correctly trace rays, we can determine how an image will appear when reflected through various lenses. In order to do this, there are 3 light rays that we must trace. The first originates from the object and enters the lens parallel to its axis and exits through the lens's focal point, coming in parallel and exiting through the focal point. The second light ray originates from the object and passes straight through the center of the lens. Finally, the last ray originates from the object and passes through the focal point on the same side as the object. By tracing these light rays, we can determine both the size and orientation of the object, seeing if it will be magnified and if it will be right side up. Finally, we can determine where the image will be projected if we know just a few things about the situation. According to this equation, the height of the image and the distance of the image are inversely proportional to the height and distance of the object from the center of the lens. So, we can use this image to figure out where an object is, how large that object will be, or how large an image will be reflected and where it will be reflected. The information is very useful and is used in everyday life. Whenever you go to the movie theater, the movie images are magnified through the lenses in order to be so clearly projected onto the big screen. Anytime scientists use microscopes or telescopes, or even when everyday people use their glasses or contacts to see, lenses help to magnify or reduce the size of an image to help make life easier. There are three types of images that can be formed. First are images formed by convex lenses and an object that is farther away from the lens than its focal length. The image appears inverted and smaller than it really is. An object closer to the lens than its focal length will be upright and magnified. The second type of image is a virtual image, which is formed by a diverging lens when an upright and magnified version of the object appears to be behind the object on the same side of the lens. No light rays actually converge there, so these images cannot be projected, hence their name, virtual images. Finally, the last type of images are formed by a diverging lens and creates an upright image that is smaller than the object. It is a virtual image, therefore is found on the same side of the lens as the image. However, the image is between the lens and the object, creating an image that appears to be smaller than the object. In summary, we can use the shape of a lens as well as the focal length or power of the lens to determine how an image through that lens will appear. Knowing the focal length and distance from the object from the lens, we can easily determine the image's size, orientation, and whether it is a real image or virtual image.